Well, hi there, Karina. Come on and join the class. All right. So we got tangent of A plus tangent of B, and we divide it by 1 minus tangent of A times tangent of B. But if it was minus, this would also be minus, but this one would be plus. So it switches accordingly. I had that in your notes. That's the formula. Now we got to make it work. Yeah. Per advice of my first hour students, third hour students, we're going to do a couple examples. It'll help you a little bit. So first one starts out the exact value of tangent of 19 pi over 12. I don't want to do that one. We'll do that one second. First, we're going to do something else. So you're not going to have to do this section. So let's do just the tangent of 15 degrees. You're not going to end up doing this. So you can, whatever you want to fill in space for tangent 15, this will be a nice example, okay? I used to do this, and nobody ever uses it, so I've never used it in calculus, so I figure why teach it. If you need to learn someday, you can learn. It's not a big deal. Tangent of 15, I'll write as a sum or a difference. Difference, tangent of 60 minus 45, sure. No, okay, all right, see, there you go. If I'm going to choose to show you a little bit more difficult of a situation, I'm going to choose 45 minus 30. Okay? So we'll understand choice here then in a second. That's something I haven't talked about before. I need to start building that in. So this would be the tangent of 45 minus the tangent of 30. Divided by what? What is the tangent of 45? Tangent of 45 is 1. What's the tangent of 30? 33 over 3. Over 1 plus tangent 45 is 1 times the root of 3 over 3. Do 1 plus 1 to get 2. So you gotta do 1 times that first. All right. Here's where choice comes in. So Quinn right away said, let's do 60 degrees minus 45 degrees. That would have come out the same. And that's a better choice. I'm going to show you the harder one so that you can understand why we would choose this one. But the reason why we would choose 60 and 45 is the tangent 60 is the square root of 3, and tangent 45 is 1. So you see why I like to work with those as opposed to these? Yeah. Okay, so a lot of people, when you're kind of going through here, if you can choose ones that work out nicely instead of a fraction, it's generally a better choice. I'll show you how this fraction works out, so then, in case you run across it, you'll know what to do. All right. So this is a complex fraction. In order to deal with this complex fraction, I first must find common denominators. So I will rewrite 1 as 3 over 3, and I'll rewrite 1 as 3 over 3. So therefore, I have 3 minus the root of 3 over 3 over 3 plus the root of 3 over 3. How do you simplify that complex fraction? Multiply by the reciprocal, so times 3 over 3 plus the root of 3. What happens? 3's cancel. leaves you with 3 minus the root of 3 over 3 plus the root of 3. Oh boy. I'm going to leave my answer like that. Why? Got to rationalize the denominator. So how do you rationalize the denominator when there's a binomial? Starts with a C, rhymes with conjugate. Conjugate. So multiply by 3 plus the root of 3, or 3 plus the root of 3. 3 times 3, 9. Oh, what did I just do? I'm sorry. We'll just change that to minus. Sorry about that. 9, and then you have 3 times negative root of 3 plus 3 times negative root of 3 will make negative 6 roots of 3. Yes? Okay, so I got to FOIL this out, right? 3 times the negative root of 3 and 3 times the negative root of 3 will give me 6 roots of 3, right? Negative 6 roots of 3. And then what's the negative root of 3 times the negative root of 3? Positive 3. Over, the whole reason behind multiplying by the conjugates is so that the middles cancel, they go away. So you get 3 times 3 is 9. And is it positive 3 or negative 3 that you get? Square root of 3 times square root of 3 is square root of 9, which is 3. And it ends up being negative because of the negative sign. So we got minus 3. So we'll simplify that. 9 plus 3 is 12 minus 6 roots of 3 over 6. 12 over 6 is 2, and 6 over 6 is 1. So the correct answer is 2 minus the root of 3. Kind of a lot of work for just... And the fact is that after we set up the formula, that went quite easy. It was dealing with the complex fraction that really took all that time to rationalize the denominator. So can I show you what works out if you make a good choice? Okay, let's make a good choice by doing problem number 3 right here. Okay. It says find the exact value of tangent 19 pi over 12. First of all, most people don't like to deal with radians, so we convert it to degrees. So I take 19 pi over 12, and I multiply it by 180 over pi. 285. So I want to find the exact value of the tangent of 285. Any numbers that add or subtract to 285 that you want to use? $45 and 240 would work. Yep, we could do that. 270 and 15, but we don't really know 15. Do we? So let's use 45 and 240. And the reason why those are good choices is the tangent of 45 is 1. The tangent of 240 is the root of 3. Right? As you look at your sheet, tangent 240 is the root of 3. So, I'll write it as the tangent of 240 degrees plus 45 degrees. Let's now express that in the form of our formula. We got tangent of 240, tangent of 45 over 1 minus tangent 240 is tangent 45. What's tangent 240? Where'd you find that? On the unit circle sheet. So you either got to know it, or you got to construct a unit circle, use your 30, 60, 90, or you got to look at your table. So you got to do it one way or the other. Tangent 45, what's 1? Divided by 1 minus, what's the root of 3 times 1? Root of 3. So I don't have a complex fraction now, do I? So see why this was a good choice? Yeah. I mean, you could have chose, let's see. Yeah, you could have made some other choices that wouldn't have worked out as nicely. So you want to try to choose something that works out to the root of 3 and not the root of 3 over 3. So let's multiply by what to get rid of that? Conjugate, which is 1 plus the root of 3, or 1 plus the root of 3. Root of 3 times 1, root of 3. Root of 3 times the root of 3. Conjugate will be the same as the base, as the denominator, just we change the sign. Just change the sign. Root of 3 times root of 3 is 3. 1 times 1 is 1. And 1 times the root of 3 is the root of 3. Over 1 times 1 is 1. Middles cancel. Negative root of 3 times positive root of 3. Negative 3. So we'll do top first. 3 plus 1. 4. Root of 3 plus root of 3. Roots of 3. And 1 minus 3 is negative 2. Is everything divisible by negative 2? So divide it. Negative 2 minus root of 3. And if you actually tried that, I did the tangent of 285, I get that. If I did negative 2 minus the root of 3, I get the same thing. All right, one more part. No big deal, it's just a proof. Rumor has it you guys really like proofs. Ooh, who said they hate? Who used the word hate? All right, wow. Loathe. How about loathe? Despise. Distaste. When I say the word proof, I throw up a little bit in my mouth. That's it. Okay. All right. I love proofs. I hope you guys learn to love them too. They're not as bad as what you maybe got a taste for. This is actually pretty nice. And a lot of times proofs rely on using a specific formula that's defined. So I'll do one example for you here. It says prove that the tangent of pi over 2 minus u is equal to cotangent of u. What does that mean? What is pi over 2 in degrees? So this is that the tangent of 90 minus u is equal to the cotangent of u. So that means, let's say your angle is 30. The tangent of 90 minus 30 is 60. Should be the same as the cotangent of 30. Yeah, that works out. It's the same as sine. The sine of 60 is equal to the cosine of 30. Okay? So there's a relationship that exists between them. What we want to do is prove that that's true. And so we're going to use our formulas from yesterday, and we're going to rewrite this tangent piece as the sine of pi over 2 minus u divided by the cosine of pi over 2 minus u. Now I'm going to see if I could get that to work out to be cotangent, because I know that tangent is sine over cosine. Well, let's expand this like we did yesterday. How would you expand sine of pi over 2 minus u? Sine of pi over 2 times what? Cosine of u. Plus or minus the cosine of pi over 2 times the sine of u. Divided by, expand the bottom. Cosine of pi over 2 times cosine of u plus or minus plus okay. So u is a variable. It tells us what we want for an answer in the end. We want cotangent. That's what we want. But we got to make it work out. So the u's will probably stay, but let's look at the pi over 2 piece. What is the sine of pi over 2? Sine of 90 is 1. So this piece right here becomes 1. This piece right here becomes 1. What's the cosine of pi over 2? 0. So this part becomes 0, and this part becomes 0. So if cosine of pi over 2 is 0, what happens to this whole piece? Goes away. And this piece goes away. And if that's 1, I end up with just cosine of u. Since sine of pi over 2 is 1, I get 1 times the cosine of u, which is the cosine of u. And in the denominator here, I get 1 times the sine of u, which is just sine of u. What's the cosine of u divided by sine of u? Cotangent of u. Yeah, that's your proof. Now, there's one more step. You got to finish the proof. And there's all sorts of ways in mathematics we finish the proof. You could write the 3 letters QED, which is Latin for that which was to be demonstrated has now been shown. Or you could put a little box. Some people like to put a check in it. Some people like to write the word done. Some people actually underline it then, maybe put a period. But you gotta end your proofs. It's kind of that sign that we've moved up in the world of mathematics. Yes. No, boxing it doesn't. QED is it's a Latin acronym for that which was to be demonstrated has now been shown. A lot of people just want to box cotangent. I know the answer is cotangent. It told me in the beginning. So you got to put something to say, I'm done. Again, boxing the answer, we know that that's the answer. So that it doesn't really... It's messed up. Oh, wow. Okay. Go tell that to a bunch of mathematicians. There's your assignment. Go. Rest of the time to work. Oh, Mr. Getz, you're so wonderful for giving us a lot of work time today. Thank you so much. Mr. Getz, you're so kind for letting me join your class for a second period. I'm lucky that Korean's in here. Wow. Listen to that. Megan Lindley standing up for everybody.